Welcome back everyone. At the end of this video, you should be able to find the limit x approaches a fx over limit x approaches a gx, where there is the case that we get 0 over 0. So there are two methods to solve it. The first one by using factorization, second by using multiplication of conjugate. Let's start with example 5. Find the limit x approaches 1 for the function x squared plus 2x minus 3 over x squared minus 3x plus 2. So we can use direct substitution. When you substitute x equal to 1 into the function fx, then we get 0 over 0. 0 over 0 means undefined. But in limit, we don't want to find the exact value of fx when x equal to 1. Limit just to see the behavior of the graph of the function when x near to 1, when x approach to 1. So we must do something for this case. This case we call as indeterminate form, IDF. Okay, so what we can do is we can use factorization method where we need to cancel out the common factor. So at the numerator and denominator, we have quadratic expression and we can factorize into x plus 3, x minus 1 for the numerator, and for the denominator, we can factorize into x minus 1, x minus 2. And we can see that there is the common factor for both function, which is x minus 1. Therefore, we can cancel out x minus 1, and what we left here is the limit x approaches 1, x plus 3 over x minus 2. So once again, we can use direct substitution where we just substitute x equal to 1 and we got negative 4. It means that when the value of x approaches 1, then the function is approached to negative 4. Example 6. Find the limit x approaches to x cubed minus 8 over x squared minus 4. So we use direct substitution, and what we have here is 2 cubed minus 8 over 2 squared minus 4. And we get 0 over 0. 0 over 0 is undefined. Okay, there is something that we need to do here. So what we should do is we can factorize the equation. So for the denominator x squared minus 4x, we can factorize into x minus 2, x plus 2. But how to factorize the cubic expression? So in the last semester, we have learned about long division. Therefore, we can use long division to factorize the cubic function. But first of all, we need to determine what is the factor for this expression. Okay, either x minus 2 or x plus 2. Then we check. Okay, first of all, we choose the first factor, which is x minus 2. Okay, we substitute x equal to 2 and we get 0. It means that x minus 2 is a factor of x cubed minus 8. So by using x minus 2 as a factor of x cubed minus 8, then we can perform the long division. After that, write your answer in the form of px equal to quotient times divisor plus remainder. And we know that since we divide the expression with factor, therefore the remainder is 0. So what we have here is x squared plus 2x plus 4 times x minus 2. So we can see that we can cancel out x minus 2 and we have limit x approaches to x squared plus 2x plus 4 over x plus 2. And once again, we use direct substitution to evaluate the limit where we just substitute x equal to 2 and we get 3. Example 7. Find the limit x approaches 9, square root x minus 3 over 9 minus x. So we use direct substitution where we substitute x equal to 9 and we get 0 over 0. 0 over 0 is undefined. This is indeterminate form. Therefore, we need to do something. Since there is set function, then we can use multiplication of conjugate to evaluate the limit. The conjugate we get from the numerator where we have square root x minus 3. Therefore, the conjugate is square root x plus 3. Multiply the numerator and the denominator with the conjugate. Then, we need to expand the numerator only because square root of x plus 3 is the conjugate of square root of x minus 3. Do not multiply the denominator. So, after you multiply the numerator, we have x, this one, plus 3 square root x, this one, minus 3 square root x, and finally, minus 9. 3 square root x minus 3 square root x is 0. Then what we have at the numerator is x minus 9. Remember, for the case 0 over 0, we need to find the common factor so that we can cancel out the common factor and evaluate the limit. But what we have here is, at the numerator, we have x minus 9 and denominator, we have 9 minus x. Therefore, we need to factor out the negative at the numerator. Then, we got 9 minus x. And we can cancel out 9 minus x. Then we evaluate the limit by substituting x equal to 9. And finally, we get negative 1 over 6. Therefore, when the x approaches 9, then the function approaches negative 1 over 6. Let's try example 8. Find the limit x approaches 0 for the function square root x plus 9 minus 3 over x. We directly substitute x equal to 0. So we get 0 over 0. Since there is set function, then we can use multiplication of conjugate to evaluate the limit. So the conjugate is square root x plus 9 plus 3. We just expand the numerator because we get the conjugate from the numerator. And we can see that x is the common factor and we can cancel out x. Then substitute x equal to 0 to evaluate the limit and we get 1 over 6. Example 9. Find the limit x approaches 9, x squared minus 81 over 3 minus square root of x. We directly substitute the value of x with 9 and we get 0 over 0. This is indeterminate form. We need to do something in order to evaluate the limit. So, what we can do is, we can use multiplication of conjugates since there is set function in the question. So, the conjugate is 3 plus square root x. We just expand the denominator because 3 plus square root x is the conjugate of 3 minus square root x. 3 plus square root x is not the conjugate for x squared minus 81. Therefore, do not expand the numerator. So, this is what we get after we expand the denominator. But remember, we multiply the conjugate is to get the common factor so that we can cancel out the common factor. But in this expression, in this question, after we expand, there is no common factor here. So what we can do is, we can use another technique, another method to solve this question. So x squared minus 81, we can factorize into x minus 9 and x plus 9. So for the denominator, we factor out negative 1 and we have x minus 9 as the common factor, and we can cancel out the common factor. Now we can evaluate the limit by substituting x with 9 and we get negative 108. So what we have learned in this video is, when we have indeterminate form or IDF, where we get 0 over 0 after we substitute x equal to certain value into the function, then we can use either factorization or multiplication of conjugate to evaluate the limit.